നമ്മൾ പറയുന്നത് നമ്മുടെ മ്യൂട്ട് ആക്കി കഴിഞ്ഞാൽ സ്ക്രീൻ റെക്കോർഡിൽ നമ്മുടെ മ്യൂട്ട് ആവുന്നതല്ലേ ഉള്ളൂ. നമുക്ക് വേണ്ട, നമ്മളിപ്പോ ഒന്നും പറയുന്നു. ഇപ്പൊ മ്യൂട്ടായി. ഇപ്പൊ നമ്മുടെ മ്യൂട്ടാണ്. നമ്മൾ തുടങ്ങാൻ നേരത്തെ മ്യൂട്ട് മാറ്റിയിടണം കേട്ടോ. നിങ്ങൾ പറഞ്ഞ് കഴിയുക, നമുക്ക് വേണമെങ്കിൽ അൺമ്യൂട്ട് ചെയ്യാം. അങ്ങനെ തുടങ്ങുമ്പോൾ പിന്നെ ഓർത്തോണം. നിങ്ങൾ ടാങ്ക് വണ്ണുകാരല്ലേ? പക്ഷെ നമ്മൾ പറയുന്നത് സ്ക്രീനിൽ റെക്കോർഡിംഗിൽ വരും. അതെ, അവര് പറയുമല്ലേ. പിള്ളേരെല്ലാം പ്രസന്റ് ആണോ? എല്ലാ ടീമിലും അറ്റ്ലീസ്റ്റ് ഓൺലൈനിൽ. ലെവിനെ കാണാൻ പെട്ടെന്ന് കയറിയില്ലേ?
Good morning, esteemed guests, distinguished researchers, and respected attendees. It is our pleasure to welcome you all to this track session of the National Conference on Intelligent Computing and Secure Technology, NCIST 2025. As technology advances at an unprecedented pace, research in intelligent computing and secure technology has become the cornerstone of innovation. Today, we have the privilege of witnessing groundbreaking research that contributes to shaping a more secure and intelligent future. We are honored to have with us Dr. Lena Sylvester M., who will be guiding our discussions today. She is a PhD holder in Computer Science and Engineering from Nurul Islam Center for Higher Education, Tamil Nadu. She is currently working at the College of Engineering, Karnataka, with 23 years of experience in the field. Her research interests include machine learning, pattern recognition, and image processing. She has authored 9 papers in international journals, presented at 2 international conferences, and contributed to 1 national conference. Dr. Lena Sylvester has served as the principal investigator for research projects funded by the Center for Engineering Research and Development, CERD, under KTU. Additionally, she has mentored and guided several student projects. Before we begin, I would like to kindly remind everyone please to mute your microphones unless you are speaking to ensure a smooth and interruption-free session. Without further ado, let's begin with our first presentation. To commence the session, we invite our first team to present their research on classroom engagement tracker, RFID, and facial recognition for enhanced learning, paper ID 6G, authored by Levin M. We invite Levin M and team to present.
Okay. Okay. A warm good morning, everyone. Today, I'm very excited to be here at NCIST 2025 to present a research paper titled "Classroom Engagement Tracker, RFID and Facial Recognition for Enhanced Learning." I myself am Levin M, joined by my teammates Abhijit, Mirza, and Yasin, who have played a crucial role in this project. Over the next few minutes, I will walk you through our research, highlighting its key objectives, methodology, and the impact we hope it will have on modern learning environments. Now, for the introduction. Now, first I must ask, what is classroom engagement? Now, engagement is not just about students being physically present. It's about their active participation in the learning process. However, traditional classrooms often struggle with inefficiencies. Manual attendance tracking, for example, is tedious and very prone to error. Teachers also face many challenges keeping students engaged. Now, this is where EdTech or education technology comes into play. As a rapidly growing field, it enhances the interactive learning experience by integrating innovative tools and technologies from AI to simple hardware to create a more efficient learning environment. Now, given the challenges I explained above, there is a clear need for an automated system that can improve classroom management. Now, that brings us to our problem statement. Now, currently, manual attendance tracking is inefficient. That is, it takes a valuable teaching time and often leads to many inaccuracies. And not only that, monitoring engagement of many students is very difficult and challenging for the teachers themselves. Now, additionally, teachers themselves have a heavy workload on top of all this for balancing lesson planning, grading, classroom management, etc. Now, I believe and we believe that creating an efficient solution to solve this involves a few key parts, which is to mainly automate the attendance process, track behavior of students real time, and to derive necessary data from students to provide to teachers as to aid in a better learning process. Now, now, I must say that several studies have explored solutions to these challenges. Here, we will be discussing mainly three of them that we have looked at. Now, for the first paper, an improved version of student attendance management system based on RFID. It integrates RFID systems with face recognition technology. Now, the system uses a pre-trained convolutional neural network to match captured face with pre-stored image data in a centralized database. Now, uses multiple cameras situated around the classroom to capture video footage of the students of the students. Now, the system applies face detection and recognition algorithms for not only capturing attendance but also recognizing the behavior of the students themselves. Now, this involves analyzing the postures, facial expression, and focus levels based on their upper body upper body behaviors. Due to this, accuracy of attendance procedure is even further enhanced. Now, going to our proposed solution. Now, taking in account of the previous papers I have discussed before, we propose an advanced solution to address the challenges faced in traditional attendance systems. Now, our system here leverages a few key technologies, that is mainly RFID cards, face and behavior recognition technology, and a simple web UI interface for teachers to enhance accuracy, security, and create a more efficient classroom environment. Now,
Can you explain in detail about this? You are just focusing on the user interface design and all the things. What are the core and what are the design to work with investment area which is very yes, yes, yes.
I apologize for the interruption there. We are having a bit of network issues here. Now I'll continue where I left off. Now I was at the system architecture part. Now, now our system. Now, our system mainly consists of a few key components. Now, to describe it, what do you say? You can see the RFID module, facial recognition module, student behavior monitoring, database storage, and teacher dashboard UI interface. Now, how it works is simple. First, the RFID module, where each student is assigned an RFID card. Upon entering the classroom, the students scan their cards and the system records their presence. However, unlike traditional RFID-based attendance system, there is an additional facial recognition security on top of it. Now, the camera stores student's face and cross-verifies it with pre-stored data in our database, ensuring only the right student is marked. Now, this effectively we aim to eliminate proxy attendance. Now, about our behavior recognition module, it analyzes student engagement levels by tracking facial expression and posture. Now, this attentiveness and classroom participation is valuable insights for teachers for aiding the individual students' learning experience to deal with them. Now, to make the system user-friendly, we have developed a web-based UI for teachers, which allows real-time monitoring of attendance records, and engagement levels, behavior insight, etc. Now, looking into more particulars of the system, at first, I must say that the RC522 RFID module, now about the RFID based attendance system, the RC522 RFID module is connected to ESP32 microcontroller, which is installed in a classroom. Now, this place is where NFC cards are scanned to mark the attendance. Now, OpenCV is used to capture real-time images, which are then processed by DFace VGG model for feature extraction and matching with the pre-stored data. Now, going to behavior detection for sleep detection. We detect the students who are falling asleep by using a hard cascade model of detection. The camera continuously tracks eye movements along with the head posture to determine if a student is sleeping. The student's eyes remain closed for an extended period of time, or if their head is tilted for a period of time, the system flags them as sleeping. Now, similarly, we check if a student is using a mobile phone or not by using YOLO V5 model. Now, and if the previous models detect a malicious activity or the undesired activity, that is, if a student was marked as sleeping or using a phone, a report is generated with the time and date it occurred with which undesirable activity happened. Now, this seamless integration of these technologies has resulted in a more robust real-time monitoring system. Okay. Now, going to results, mainly the keywords here used are accuracy, precision, and recall. Now, accuracy mainly measures how many predictions the model got right out of all the predictions made. The precision means how many positives which are actual positives. Uh, model flag is correct. Now, finally, recall, which is also known as sensitivity, tells us how many actual positives were caught. My word, the precision actually explains how many positives the model flag which are actually correct. Now, the important insight here is that the RFID attendance system is most reliable, as in it has the highest accuracy, precision, etc. While the behavior detection ones lag behind the most, and this is because the vagueness associated with what counts as sleeping or phone detection, phone usage compared to a more defined fixed feature like NFC card. Now, about the challenges we faced in our development, mainly it. I must say there were technical difficulties. One particular thing that comes to mind was extremely high number of false positives due to when using that were flag when using a mobile phone. That is, if another object similar to a mobile phone were used, it used to flag it as using a mobile phone. Now this was initially caused by a usage of DLIP, but when we switched to YOLO Wi-Fi, a significant decrease was observed. Now, the second one is that there is a high initial cost of setup. That is, first we were planning to use it with a large number of surveillance camera, which proved to be very expensive. But using a laptop's webcam decreased the cost significantly. Now, third is that the privacy and ethical concern that are associated with this with this project. Now a continuous video monitoring and storage of student video is a breach on privacy of the student. Now, this this is why we have decided that instead of storing the video itself, it's better to simply provide the timestamp, date, and behavior in question of the student. Uh, Now, about future scope, mainly we plan to integrate emotion recognition as an additional feature for deeper insight to determine how to enhance the classroom engagement. That is to see if to improve on the insights gained from student monitoring. Now, second one is cloud-based storage and scalability. That is to uh, use a dedicated cloud-based system like Azure instead of the localized database version that we are currently using. Now, the third one is advanced data analytics and predictive insights. Now, mainly means to use advanced data analysis models to provide more valuable insights about the student behavior from additional data gained from the students. So, we are nearing the conclusion here. So, as a conclusion, I must say that we would like to emphasize that the integration of AI and IoT in education is revolutionizing classroom engagement. And our system is a primary example showing how this integration can enhance efficiency, fairness, etc. Ultimately paving the way for smarter learning environments. With continuous advancements in education technology, we believe that smart classrooms will soon become the standard, creating a more interactive and data-driven approach to learning. That's all. We are happy to take any questions. Thank you.
Now, we would like to open the floor to the track chair, Dr. Lena Sylvester M, for any comments, questions, or feedback on the presentation.
You didn't include any reference in the slide, Levin?
No, miss, one second. Okay, here you go.
Can you explain how sleep is detected?
Sleep, Miss, so, Miss, basically what we're doing here is, as in surface explanation, all we are doing is detecting if the student's eyes are closed for a specified amount of time. That is, at this point, in our project, we use 2-minute mark for seeing if the student is sleeping. Or that is tilted
Which model is used?
to a certain manner.
Actually, audio.
No,
There is some
no,
disturbance.
we use
Hello. Which model is used?
Miss what?
Which model is used? What kind of improvement is done here?
We used another alternatives like D-Lip, but it is slower than the hair cascade. We use media pipe, face mesh, but it is high. It needed high processing powers, so we chose the hair cascade, which is also a lightweighted.
Okay, you had experimented on media paper and all.
Yes, ma'am.
So you have to include those things in your paper.
Oh.
You can include that.
Yes, in this negatives we all this that D-Lip is slower. That's why we don't give this preference.
But it's not mentioned in your paper. Okay, next time you have to include. Okay.
Okay, ma'am.
Okay, thank you. Okay, then next presentation.
Hello, am I audible? So, is the screen visible?
Yeah.
Okay, wait. Okay. Good morning, everyone. My name is Harishankaras and I'll be presenting in NCICST, and our paper ID is 19G, titled Leveraging OCR for Harmful Ingredient Detection. My co-authors include Jeevan Jijo George, Irene Robi, Nikita Manoj Kadavan. Okay, so going into the introduction part, these are the table of contents. And the purpose of this is an application which is used to show consumers about what the harmful ingredients are present in their foods. Suppose let it be harmful substances or adulterants. We are using OCR technology, that is optical character recognition, to scan the ingredient labels from a food item and then comparing it with our databases and then showing if there are adulterants present. And all these alerts are being notified in real time. Now, the reliability of this OCR depends on the clarity of the scanned ingredients as well as the labels. It also includes the lighting conditions as well. And yeah, going into the problem statement, consumers struggle with complex labels concealing harmful substances and allergens, highlighting the need for a tool to simplify analysis and promote healthier choices. So the basic idea is to inform consumers about what are the harmful substances in this specific food item. So many problem with these food items is that there are complex names for one or a two, like there are alternative names for the same thing, and all these names we get confused. And the aim of our application is just to simplify, to make them aware of these harmful substances which are in the food items. So the objectives is to identify those ingredients, that is accurately detect and show the allergen information, as well as the harmful additive detection, that is to warn users about the harmful as well as additives and preservatives in the foods. And going into the next slide, these were the papers that we have taken for the literature survey. And the first one is a mobile advisor of healthy eating by reading ingredient labels. Now, the main methodology is that in this particular paper, they are scanning the barcodes from each of the products, and they are cross-checking it with the databases that they have already built in. And yeah, the result was the OCR speed was comparatively low, but it was much more accurate, and the users found the health solutions helpful. The limitation was that the OCR speed and the performance was low, and the language support was also limited. And taking into the next paper, we have food scan, food monitoring app by scanning the groceries receipts. This is also a paper which is based on OCR recognition, and it was published in the year 2020. And yeah, it uses receipts from a shopping cart, and OCR technology was implemented to scan these receipts and find out what are the harmful ingredients and track the purchases of those that they have been purchased, like what are the nutrient values and all. These were some of the papers that I've included in this presentation for the literature survey. And going next, this is our proposed system. Now, our application's name is SafeBite, and it's an Android application which finds the harmful ingredients from an ingredient list of a packaged product. The detailed information about the product list is freely available, and no payment or subscription is required for a specific application. And yeah, as I said earlier, OCR technology is used to detect the ingredients. Now, I've been saying OCR for quite a long time, and the OCR technology that I've been using in this project is Google Vision API. And yeah, the main reason that we chose Google Vision API is that it is way more accurate, and it is working on a cloud-based platform, so that the computation power of our smartphone or local devices are much used, and they have a wider data set to scan these OCR related matters. And the application operates as an independent entity, delivering unbiased assessments of food products. This is the proposed system. And going forward, this is the system architecture of our application. It's a fairly easy one. There is the user. This is the app UI. The user is interacting with the app UI. The app UI is then scanning the food labels with the OCR, and we are using mobile system and the camera to scan. Once the picture is captured, it is being scanned using the OCR, and the text is being processed, and the ingredient list is passed to the databases. The database is what we have already inputted, and we have taken the database from various resources such as FSSAI from the Indian government, as well as Food and Drug Administration of the American governments. Like, we have combined many databases, and we've made a combined databases, and that is what we're using. This is a localized database, and after comparing it, we are generating an output. So this is the basic system architecture of our application, and these are the hardware as well as the software requirements. The main thing is that some CPU powering is there, and then main hardware is the Android device with a camera, and for the software it should be Android. This is how we have developed the application. Moving on, this is the module description. There are 3 modules in our application. There is the login as well as the sign up pages, which is used to identify each and every user, and which is secured by ID and a password for the privacy of all those users. And then the homepage consists of the scanning of those products, which includes scanning the ingredients. That is as the main focus is, that is the homepage. And there is an allergen support, wherein users can add in their allergies. If I am lactose intolerant, and I can add into the application that I am lactose intolerant, like there is a column which is used to add in allergies. And if an allergy is being detected, it is shown as an allergy in the application. We will see it in the next slides in the result and outputs. I'll show you. And this is the data flow diagram in the level 01. This is a fairly simple one. And in there are admin module as well as the user modules. In admin is actually giving up the information of the database that I've said earlier. and user is given the details as well as ingredient, and the application will give a generative report on the analysis. This is the level 1 and this is the level 2. I'll tell detail about the level 2 as level 2 is a bit more advanced. So we have the login and sign up page, and the one which is represented in rectangle is the databases. Users can log in with the user details and can also register. In the scanner module, we are using the phone camera to capture the images, and it is being stored into a temporary ingredients list for the sake. And then from this ingredient list, it is being transferred from an image to a text, and it is being categorized. In the products that we are scanning, most of the labels are like separated by using a comma. So by categorization is what I meant is that we are using the comma as a separator. Suppose in the first ingredient, let it be maltodextrin, and the next one is flour. That would be separated by a comma. While categorization, what it does is that we use the comma as a separator and we categorize it each one by one. After categorizing it, we are comparing it with our standard values, that would be the databases that we have inputted, and at last a result is being generated. If there are any allergies present, the allergens information are also being highlighted in the output. So this is the data flow diagram. And since our module consists of databases, there are three main databases in our project. First one is the harmful one, which has two tables, ID and ingredients. As the name suggests, it stores the ingredients as well as which is identified by each ID. Second table includes the user details such as the email, name, password, the username, image, and the third one is the allergy table, wherein the user as well as the allergy table is being connected in a relation of 1:n. And the allergy table is being connected with the primary key ID and the foreign key user ID. And allergy usually stores if a user has certain allergies as well. It is specific to certain users. Moving on. This is the ER diagram, which is the representative format. Both are kind of, this is the structural one, and this is the ER diagram itself. And this is the sequence diagram. Essentially, what I said is happening is shown here. There are like user, scanner, database, analysis, as well as the notification.
Slide.
Okay, fine. And this is the implementation. Yeah, the data we collected from the harmful ingredients can be added to a product. Using the OCR of Google Vision, we can extract the ingredients data from these products, and these are compared using a database, and then it is shown. And if the allergy data is being detected, it is shown in the output as well. This is the basic implementation of our project. And this is the result page. The one detail that I missed to add is that in our application, the reliability certainly depends upon the scanned labels. That is, if there is the full text isn't visible, for instance, there would be some challenges for the system to actually read those labels. So it entirely depends upon the way we scan it and the lighting as well. If it's a clearer text, it would be more concise. As the lighting as well as the accuracy of the text reduces, the accuracy reduces as well. So if I have to say it in terms of numbers, if there are good lighting conditions, it is about 80% accurate, and as the lighting conditions degrade, it reduces as well. So this is the output page, and there are the sign up as well as the details where you can sign in and register for each user. This is the home page where you can scan the product. After clicking in this, you will go to a camera and you can actually scan the ingredients list. This is the allergy tabs where you can add in allergy for each user. Suppose in this scenario, G1 has, if I have added gluten, dairy products and peanuts, if it is being like shown in the ingredients, then it is being highlighted in the output page. Now this, after scanning, this would be the output, and each ingredients are separated like down line by line. And if there are any harmful substances present, then it would be highlighted in red text as well. And if in the allergy tabs, if I had inputted edible vegetable oil as my allergy, then it would be present over there. And that would be the result. And what are the advantages of our application? Well, main advantage is that it's cost efficient, and we don't want to spend money on this to obtain information about the harmful substances. And the second one is harmful ingredient detection, like I have mentioned in the previous slides, and the allergen detection. These are the advantages. What are the challenges that we had faced while making this application? The main challenge that we had faced was the collection of the data. Like we had to score through data from many resources and had to compile it into one single database. And the second challenge which we faced was to integrate the OCR module. We had compared many modules, and the most reliable one came out to be Google Vision. Since the most of the processing is happening on the cloud server, it reduces the load from our server as well. So due to that reason, we have included Google Vision API for our OCR module. And the other challenge was the setting of the server and integrating with our applications. And yeah, precise output cannot be generated due to the limitation that I have said earlier. It depends entirely on the lighting as well as the conditions on which the photo or the text is being taken. Now, what are the future scope? How can we enhance our application? Well, right now our application supports English language, and in the future we can actually include many more allergens as well as the harmful ingredients to make our databases bigger, and we can also collaborate with research institutions as well. Multilingual support include many other regional languages, and as of now it's only available in English. And the third future scope that we are aiming to achieve is offline functionality. Right now our app is running on online mode because Vision API can only be accessed through clouds. So a stable internet connection is required. And the fourth one is error correction. As I said earlier, with the accuracy of 80%, we can actually increase it by implementing Levenstein's algorithms as well. Levenstein works in by approximating text matching. Suppose if I scan an ingredient label, and if I get car and actually I want it as bar. So what it does is Levenstein algorithm goes into the whole of the databases and then scans it with the most accurate, like what is the nearby ingredients. Yeah, that is the future scope that we are trying to achieve. And this is the conclusion. That is the support for dietary needs. Like it helps users, especially those with specific dietary requirements, make informed food choices and unbiased information. Like our app is an independent app and we are impartial with the ingredients analysis. Yeah, it ensures being trustworthy as the information is unbiased. It gives real-time feedback on what is good and as well as what is bad. And it also makes the users make an informed choice on what to eat and what not to eat, promoting healthier eating habits and a healthier relationship with food. And these were the references that we had used while making this application. As you can see, there are about, and this is the publication that we had already used. Like in this AI Transform Education Society was the first paper that we had used to publish the literature survey of our paper. And yeah, it was published in this. And thank you. Any questions?
Is it your mini project?
No.
Okay, in your paper, you mentioned that the average accuracy is about 85 to 90%. How you got that?
It is well, the Vision API documentation says that it gives an accuracy, but it entirely depends on the lighting that I've said previously.
So you have to prove it. How we can conclude that it is around 85, 90, like that?
In our testing in ideal conditions, it proved to be working perfectly well. But as the conditions deteriorated, suppose it would be lighting.
No, you have to theoretically prove it. You can produce some graph or you can use some measures like that you have to use. Otherwise, you can mention like this, our accuracy is around 85 to 90%. You have to use some measures.
Okay.
Why you mentioned accuracy can drop to 70 to 75%?
Because yeah, as I've told earlier, it entirely depends on the lighting factors. Because we are using camera, right? We are using the mobile's camera, and as the camera quality,
you can't mention the number 70 to 75.
I'm sorry.
Where you got these numbers? Maybe from ChatGPT.
Yeah, we had used many other documentations as well.
No, you can't use like that. You have to prove it using some measures. In the poor lighting condition, you can measure, you can use some mathematical equation and prove it is around 70 to 75. Otherwise, you can't use it in your paper. You have to use some measures.
Okay, miss. We'll do.
So you send it to the LC where?
Can you ask it once more?
It's written, it is a preprint submitted to LC where?
Yeah, the format is elsewhere, yeah. We have written it in elsewhere format, yes.
Okay, what is the improvement you have made in here? Which kind of improvement is made? Lot of corrections are there in your ER diagram, and the sequence diagram is not correct. You have to mention the relationship in ER diagram and all. Actually, your design part, can you take that hardware requirement slide? Here you wrote CPU. What is the meaning of this first line?
Okay, so the first one, the server
You
that
had
we're running.
used 13 processor.
No,
Did you
what I made is
13 processor or i3 processor?
i3. It was an error.
Okay.
For the hardware requirements, the thing is that we are actually running the server as our laptop for the sake of the project.
A lot of corrections are there in paper also. It's actually a copy paste document. Lot of mistakes are there. You have to be careful. Okay.
Okay.
Okay. Okay. Let's proceed to the third paper.
Sincere appreciation to the team for their engaging presentation and for shedding light on such an important topic. Next, we invite Amrita Sunil and Donna Binu to present their papers titled AI-based legal advisor, identified as paper ID 20G. Next one, we invite Amrita Sunil and Donna Binu.
Yes, ma'am. I'm just connecting. I'm just trying to screen share. Is it visible?
Yes, yes.
Okay. Good morning, esteemed members of the board. I'm Elizabeth Rachel, and I'm representing my team from College of Engineering, Chengalur. We're excited to present our project, which is an AI-based legal advisor, paper ID 20G. Our team members consist of Amit Sunil, Donna Binu, Elizabeth Rachel, and Elza and Thomas under the guidance of Leah G. These are the table of contents, and it's a roadmap as to how we have proceeded with the project. To introduce, legal services today, they're often very expensive and complex, and they often limit access for common man in order to navigate legal challenges. So our main project is to leverage AI in order to simplify this. How we do this is by automating tasks like document drafting and providing chatbot-based guidance. We make sure that legal support is made quick and affordable, and that it's accessible to all. This ensures that we're simplifying processes, which helps users in order to be aware of how they have to handle any sort of legal task and procedures. Our problem statement is, how I explained, is that We wanted our goal to be clear, which was to develop an AI-powered legal advisor, and that it makes sure that everyday people, they are able to access these sources without going through any sort of confusion. So we make sure that by simplifying legal jargon or solving any sort of legal queries, and by assisting them in drafting of legal documents, we're able to make it more accessible to a common man. The objectives of our project, we have got main three objectives. First is that we wanted to ensure that any sort of complex legal terms or terminologies that is used in the legal field is made more simple and understandable for non-experts. The second thing that we wanted to help in is ensuring that any sort of document that was required for drafting, like a will or anything of that sort, was in such a way that they would get a template in order to, in such a way that they're able to just customize it, and they can create an accurate and professional draft of it. The third thing that we wanted to implement was a chatbot that ensures that there is a personal legal advice according to and catered to each of the person's concerns, such that this chatbot could help the people in order to go further on how to proceed with their legal questions. Now we do have certain existing systems that is present. The first one could be mentioned as an AI legal guidance chatbot. So this is actually they use natural language processing, and what they do is that they provide personalized advice for a certain set of audience, which is survivors of sexual violence. So this is a chatbot that is already existing. So how they do it is that if a person has a concern, they guide them through how to report and how to go ahead with proceeding with the case. So that is one system that already exists. Another one was in order to assess how, if there is any case of risk that is present in legal documents, they help in analyzing how to go forward with figuring out what these risks are and how to solve it. Now, the third one that is there is it integrates AI and auto ChatGPT in order to analyze documents, and they use sentiment analysis in this in order to detect if there is any sort of irregularities. The next one is the limitations of whatever is the existing system that is present. Now, many of the existing tools, they focus on very narrow areas, like any sort of contract review, target professionals, or any, like they have a certain set of audience and they cater only to them. So what happens is that this causes a strain because they're not focusing on the public, and usually many of these existing systems, they come with a lot of high cost or sort of low accessibility. So what we wanted to do is that we wanted to broaden the scope and we wanted to prioritize inclusivity. Now, as mentioned here, it's said that it's already there is a lot of narrow focus, and the audience is not someone whom like not the common man couldn't approach with his problem to any of these systems because of the high cost. Now, we have actually used a few papers in order to use as a literature survey. So first I'll be focusing on, I'm only taking two in order to just explain what is. The first is a lawyer legal guidance through AI for sexual violence victims. Now, even this was actually, as I mentioned before, it was catered only for sexual violence victims, and this is actually only targeted for the Thai legal government and not for any more than that locality. So the limitations in this was that it only focuses on the Thai language, and so people all across the world were not able to use it. While the good side of this was that there was a lot of accuracy in the percentage, and they were able to match the cases that a person was going through with the relevant court cases that is existing. So that is the first paper. Now, the second one is a text simplification for legal domain. Even in this, here the thing was that they had text simplification, they had explored that feature, and this outlines the limitation in this was that there were parallel access of data sets was not possible here. So the thing is that they were not able to train the model well, and they were not able to completely comprehend whatever was available legally at the moment. So whatever legality or any sort of complex terms that was found, they were not able to properly analyze or simplify it better. So that was some of the problems that was faced in this paper. Now, moving on, we have the proposed system. So our system, why it stands out with the rest is that we have got few features, like we wanted to cover drafting of documents. We also wanted to help the person be able to communicate what their issues are and help them actually go forward with how they can solve their issues. And they can also get jargon simplification, which, as I mentioned, is a place where they can tell, like if there is any sort of legal terminology that they come across that they're not able to comprehend, we can use a jargon simplified in such a way that it helps them understand what that word is and how they can go forward in such a case. Also, as I mentioned, we are going for a more inclusive audience. So there are already systems that exist for people who are already legally aware. So why we wanted to go for people or like common man as an audience in such a way that they can have at least a base on how to proceed with any sort of trouble that they have at their hand. And how we ensure it is by providing a user interface that is very easy to navigate for even those who has not got a lot of tech and expertise or any sort of legal expertise, so they can go ahead and understand how to navigate and go further with it. Now we have got a system architecture. So this is how our user will be interacting with the system. As we see here, we've got a user and we have got our AI engine here. Now the three main features that we're having is document drafting, analyzer, and the legal chatbot. So here the user is interacting with these three features, and that is what the overview of our system looks like. Now these are the software and hardware requirements. So for our front end, in order to implement the solution, we have used React.js mainly because it has got reusable components. And for the backend, we've got Node.js and with Express. For database, we've used MongoDB. And in order to implement AI, we have used Gemini's 1.5 Flash API. For ensuring that there is a security, we have used bcrypt for ensuring the authentication side of it. And some additional libraries that we have used in order to complete this process is by using React Router and JSPDF. And then we've got our hardware requirements, which is Intel i3. We can use a RAM of 4 GB, and storage can be HDD or SSD. And we just need a stable internet connection to keep this going. Now we'll go forward with the module description. Now we have got the first user module would be the user authentication module. So in this, what we have is that a user, when they're accessing our system, we have got a page where the person can enter the credentials, and here what we're using is we're using bcrypt in order to ensure that there is a password security. This is done in a way that when a user enters a password, whatever the password is, it is stored in a hashed format in the database in such a way that it is not easily prone to any sort of attacks. So in such a way that authentication is done. And how we're using is by using a React state, and we've got a local storage in order to ensure that the verification status is verified. Authentication status is verified. So that is why we use React state and local storage. Now, as I mentioned, there is a password strict validation criteria that we're using in order for password in such a way that this is also to ensure that the password is not easily breachable. The second module that we have is called a legal chatbot module. This is basically where we use a Gemini 1.5 Flash model using the Gemini API. Now what this is that we get real-time legal advice by integrating this Gemini API. So this is like a conversational interface where a person can ask their queries, and we get context-aware responses that is generated by this Flash model. So that is the second module. Then we've got a legal document drafting module. So this is a place where a person can create legal documents where our system actually provides them predefined templates. So what we can do is that a person can enter the details into a form, and then you get a template, you get a required document with the help of this existing template. Now how we did it is that we did fine tuning on this Gemini model, and why we did this is because we wanted to ensure accuracy and adaptability. So every time a person enters whatever their details are in order to get the customizable template, we ensure that this was very accurate and stays within what the template is supposed to give. Now here we also have an option for them to get this as a PDF. So what we use is a JS PDF library which is present in React in order for generating this PDF. Now, why this is helpful is because in order for manual drafting, many of the times a person is not exactly aware as to which all fields or what all terms they're supposed to use. So here the time and effort that is required for manual drafting is reduced in a large amount. The next thing is a legal document analysis module. So here what it is that, as I mentioned, it is more of where a person, if a common man, if he is unable to understand what a legal terminology or any sort of notice that he is being presented, if he is not able to understand what it is, we can upload this and they can analyze this document and we get a simplified version and we can understand, a person can understand as to what it means. It is communicated in a very simple language. So this as well, text simplification is also done by this Gemini 1.5 Flash model, and it helps in giving out a proper clarified response to a non-expert. Now you've got the data flow diagram. So here we can see that there is a user and they're interacting with this AI engine as mentioned. Now the user, they help in, they give this information, that is they've got, when they log in, they given their user's ID and password, and then if they are interacting with the features, then they're asking legal questions, any sort of information that is required for drafting the specifics, everything is given. And the AI engine, what it does is that they help in providing this legal help. They give all the responses back to the user. So this is what the data flow diagram level 0 looks like. Now we've got the level 1 diagram. Now here, as I mentioned, the user, they will enter their credentials, and once the authentication is done in the login phase, we can see that the login credentials are stored in the database, and after the person has logged in, they're able to access these 3 features, which is document drafting, analyzer, and legal chatbot. And if they are accessing any of these features, they will be communicating with the AI engine, and then you'll get a response back. So this is how the first level of the data flow diagram looks like. Now we've got the use case diagram. Now here as well, we've got a user and we've got the AI engine, and this is a flow as to how the user and the AI engine communicates with each other. Now a person can log in. Once the user is logged in and they authenticated, they can ask legal questions. These questions will go to the AI engine, and then they'll give a response back. Same thing itself, they use a chatbot for drafting documents, for simplifying the jargons, and for viewing the document templates. Everything is possible by the user and the AI engine interacting with each other. And the final step the person can do is to log out. So this summarizes the use case diagram. Now we've got the implementation on how we did the project. Now, first thing we did is that we designed the core functionality and architecture of how we wanted the project to look like. So in this, we had to identify what the user's requirements were and what our functionalities was we could include. Now, in this, we designed the first phase. We had to design the system architecture. We designed the data flow diagram, and we also decided which all technologies would be the best to implement this. Now, for front end, we built the user interface using React.js with table CSS, and we did this for a better and responsive UI. We also implemented a library React Router in order to ensure there was proper navigation between the different features in the within this module. Now, we also had to use several libraries like JS-PDF. As I mentioned earlier in the presentation, JS-PDF was used in order for PDF generation when we are entering a detail. Now for the backend development, we use Node.js with Express in order to handle user requests. For database, we use MongoDB in order to store the user profiles and the chat history. Now AI model integration, we use the Gemini 1.5 Flash model in order for helping them with the chatbot and document analysis. Everything was done with the help of Gemini. We also helped in AI model was helped in order for fine-tuning these documents that we wanted, where a person could enter the details. The document drafter was also done by using this AI model. Now testing was done for each of these modules. We had done testing for the user authentication, the legal drafter, everything was done. We had testing for each phase. We also ensured that there was smooth communication between all the different phases, and any security issues that could occur was also addressed. Now, moving on to the results. Our results are promising. We have an automated legal assistant, and it is efficient in document processing, and we've also helped, it also has helped with a friendly user interface. Since we also got a strong data security, it is a practical application when it comes to the real world needs. Now, we have got an automated legal assistance. A person does not need to go in person or struggle in order to find out how to go further with any sort of query that they have. We've got document processing efficiency because of the template that we already have. It reduces manual effort significantly. With a user-friendly interface, it is very easily navigatable for a person to go use. As for data security, as mentioned, we have a very secure authentication, and it ensures that the data is protected Now this is how our system looks like. And entering, we have got our homepage, which is basically, it tells you what we are providing, what is the solution that we have, and you can see that on the left we have got all the functionalities that a person can interact and go use it. Now, if you're moving to the chatbot, we can see that this is a chat interface. A person can enter their any sort of query that they have. They can send the question, and the process, the chatbot will respond to our queries based. So, they don't go out of context. They stick to whatever our query is entirely. So this is how the interface looks like. Then we've got the document analyzer. So here we can upload any sort of document that we have got concerns with, that we are not, that a person has got any difficulty in comprehending. They can upload this document, and once we click this analyze document button, we get the simplified version right below this. Now is the document drafter. So these are the documents that we actually have templates for. So we've got divorce agreement, will, lease agreement, and NDA. So these are the documents that has got a template, and a person, if they want to create a will, they can click on will. They have a template that is present. So they just need to fill in the fields, and then after that, once they save it, they can generate a PDF of whatever their will is. So they get their will as a PDF. So this is how the template looks like. This is a divorce agreement template. So here it's a form. So the person can fill in whatever is the details that is required by the system, and once they're done filling it, we can generate it, as I mentioned. So this is for the will. We've got so these are actually three conditions that already comes selected, because these three are necessary in order to create any sort of will. So this already comes pre-filled. Now, some of the challenges that we faced is that our chatbot has got some sensitivity when it comes to queries. That is, they ask a lot of clarifying questions, and what it does is that it reduces the user experience slightly. So that is the challenge that we have at the moment. And our document formatting has got a little bit of difficulty when it comes to making it a little bit standardized when in comparison to the actual legal documents. So these are some of the challenges that we face. Now the future scope for this.
Conclude it. It's around 30 minutes.
Okay. Now for the future scope, we can work on this further. We can ensure that the AI can have better accuracy. One way to scale it is we can use voice-based assistant and integrate this in mobiles as well. And then we can also use legal databases. So this is a conclusion. So the conclusion is that we've got system functionality, which is basically we use the templates, and we have got document drafting, we've got real-time chatbot, legal advice, and we've got document analysis, and our authentication is done secure.
Okay, next slide.
I'm sorry.
Next slide.
Okay. This is our research paper status, and these are the references that we have used. Thank you.
Audience can also ask questions. Any questions from audience? Okay, what is bcrypt?
So bcrypt is actually what we use in order for ensuring. So what it does is that when a user is entering a password.
What is bcrypt? Is it a inbuilt one, or you had created it?
No, it's inbuilt. So what we did is that we had to
inbuilt with. Is it a function or library? What is it? bcrypt? Am I audible?
It's actually a library. So this is used in order for hashing the passwords.
Which algorithm is used in it? Okay, again the same question. In your result also you had made some comments like accuracy rate is 90 percentage, like that. How you got that? Again, this is also from ChatGPT. Is it your mini project?
No, ma'am, this is the main project.
Oh, main, okay. Okay, how you got the accuracy? Did you measured any similar accuracy, efficiency? You had already written the system was checked based on accuracy, efficiency, and also you had presented that your method is very efficient. How you caught it is efficient? How you can conclude it?
Ma'am, am I audible?
Yes, you are audible.
So I am one of the co-authors of the paper, and we actually used Gemini's model to for the
Okay, which LLM is used in Gemini model?
Excuse me?
Which which model is used in Gemini?
Ma'am, we are using Gemini's 1.5 Flash model.
Which architecture is used in Gemini 1.1?
It's actually a transformer-based neural network.
Tell me the exact architecture.
Ma'am, it's one of the examples of transformer-based models, which is actually.
You have to study it. Which model is behind this Gemini model? You are using the API of Gemini, so you have to study the architecture behind this model. Also, your architecture of AI-based legal advisor, that diagram is not clear in the paper. Also in the design part, also in the slides and all, you had shown so many designs. There are lots of mistakes in the designing algorithm, designing diagrams also. Can you take that hardware requirement, that slide?
Yes, ma'am. Just a minute.
Anyway, your slides are most of the content is generated from ChatGPT. Your presentation is nice. Okay, you just use RAM 4 GB for using this, for implementing this. Intel i3 and RAM 4 GB. Is it your system configuration?
Yes, ma'am.
I am not think so.
Ma'am, we designed this as a website, so it requires only very basic hardware requirements.
No, MongoDB needs some high power machines.
We're not actually using the physical database. We are using MongoDB Atlas, which is actually a cloud-based storage model. And
okay, you didn't mention like here. You mentioned it as MongoDB only. Okay, let's proceed to the next batch. Okay, thank you. Fourth batch.
A voice-based email management system, and a paper ID 25G.
Am I audible? Hello, am I audible?
Yes, yes.
Okay.
Yes, you are
Good
audible.
afternoon. Okay, first of all, good afternoon, everyone. Our project is basically based on providing a visually voice-based email system for visually impaired users. So let me share my screen. Is it, hello? Hello? Is it visible?
No. Yes, it's coming. Okay.
Okay. Our paper ID is 25G.
Okay, before beginning, actually, presentation time is just 10 minutes. Okay?
Okay. I'll try my best to conclude it in 10 minutes. Okay, starting with, before we begin, I would like to introduce my team members, Alka Anthony, Fairish Shanavas, Joel Nelson, and myself. Our project is basically based on providing a voice-based email system for visually impaired users. So moving on to introduction, our primary objective of our project is to design and develop a voice-based email system that enables visually impaired users to access and manage their emails independently. To create a system that allows users to compose, send, and receive emails using voice commands, promote digital inclusivity and accessibility, enhance the overall quality of life for visually impaired users. So moving on to problem statement, our basic idea is to develop a web-based application using interactive voice response to enable visually impaired users to manage their email accounts entirely through voice commands, such as so that they can eliminate the need of keyboard and other extended support from others to an extent. Moving on, according to our research and the information we collected, we focused on the main objectives like enhance accessibility, voice. When we studied the problems faced by visually impaired users on using email service to their convenience, we found that accessibility is quite a problem for them, as they require as email services require the use of keyboards, and they find it very difficult to use keyboards. We focus on enhancing the accessibility so that they can use the service quite easy. Uh, the next objective was to improve the security as the visually impaired users may require support from others so that they can use emails properly. So enabling them to use email services independently and in a secure manner, we addressed the issue and implemented a face recognition for securing the security. And the other is
Next slide.
okay, literature. We did survey on various papers so that we can understand the scenario and to provide a better voice-based email system for the visually impaired users. These are some of the papers we took for research survey. First one is voice-based email system with attachment for blind. It comes with face recognition with OpenCV and text-to-speech and speech-to-text implemented using Python's TTS and PyAudio libraries. And the other one is effective approach to speech-based emails assistive for visually impaired people. It uses Python speech recognition library to capture voice and Google speech recognition service to convert it into text. The system converts text to output speech using PyTTX3 and play sound libraries. The other paper is human computer interaction based smart voice email application, which uses Google WebKit API for speech recognition. And the other one was Voice Helper, a mobile assistive system for visually impaired. It uses Google okay, proposed system. Here, face recognition and face recognition based authentication. Here, users register using their face ID, email ID, and password using DLips algorithm. On subsequent visits, the system verifies the face ID to log them in automatically. And then voice command navigation. Users interact with the system via voice commands instead of relying on a graphical user interface. Commands allow users to compose, send, receive, delete, and delete emails effectively. Automated email processing. The system converts text email into speech for easy accessibility. Users can dictate emails, which are then converted into text and then sent automatically. Then natural language processing. This is to integrate AI into systems so the users can brief email description so that the system will then utilize NLP to extract essential details and employ AI models to generate contextually appropriate email. This is system architecture where the flow of the working of the system is illustrated. Here, first we can the new user can register using email ID and password. At that time, we identify the face and sort in the database. Then the existing user can log in with the with face recognition, and then they can perform actions like input, read inbox or spam, and they can compose email or read out the mail from inbox. They can move to spam and trash and read out the mails over there. And they can even compose mails using AI by reading out the subject and the recipient's name. It's completely voice interactive, so they can cross verify it by confirming, and if the reader voice is not accurate, they can retry it again so that the efficiency will be good for composing an email. And then after the use, they can log out. This is the basic architecture we proposed. And moving on to hardware and software requirements. Software requirement, we used Node.js and React for frontend, Flask for backend API development, and SQLite for database. Hardware requirement, we need a webcam for face recognition, GPU for histogram oriented and RAM at least 4 GB. Processor Intel i5 is suggested, or parallel to Intel i5, Ryzen 5 is also can be usable. Storage minimum 50 GB HDD or SSD, so that there is no, it will be run smoothly in any devices. 50 GB is recommended. Module description. The core functionalities we provide is email management. The menu page features key functionalities including composing emails, viewing inbox and trash, managing deleted emails, all accessible via voice commands. Logout functionality option is prominently displayed, allowing users to securely access the system, ensuring privacy and protection of their accounts. Composing an email, users can initiate the email composition process using voice command. Like compose an email, we can say like the system prompts for the recipient's email address. Like the voice asks you for recipient's email address, subject, and body of the content, converting spoken input to text using the SCT engine. Once the email is composed, the system confirms the details with you so that you can confirm or retry if there is any error in reading the input input voice. Inbox management. Users can check their inbox by issuing voice command like check my inbox. Like we say check my inbox, then system retrieves recent emails and reads aloud the sender's name and the subject for each email, allowing users to prioritize their responses. Users can choose their email, their needed email, so that the system will read out the full content or full content of the email, or reply to an email. They can provide voice for that. And trash management. Folder using voice command. For example, show my trash. The system reads aloud the emails in the trash, allowing users to decide whether to permanently delete or restore them. Moving on, we provide a feature from that emails can be retrieved or read out from the spam. So the spam folder fetch a feature allows users to retrieve and review emails that have been marked as spam. This ensures important messages are not lost due to false positives while maintaining security against phishing and malicious content. Okay, now moving on to text generation. AI-powered text generation uses deep learning models such as GPT to generate human-like text based on input prompts. These models are trained on vast datasets, learning language patterns, context, and grammar to predict and generate coherent sentences. The process involves tokenization where text is broken into smaller units and a neural network predicts the next words based on probability. This is the DLIPS algorithm for face recognition. First of all, the first step is to detect the face in the image using a pre-trained detector, which can be HOG or MMOD CNN. That is histogram. That is histogram. 1 minute, 1 second.
Okay, carry on. It is
Okay. Align the face by detecting the second step is to align the face by detecting facial landmarks using DLIPS shape predictor with 68 points. It marks the important features like nose, eyes, etc. Using 68 points and detects all important facial landmarks. And the third step is to normalize the aligned face to standardize size and orientation for consistency. The first is a 128 dimensional feature vector using a pre-trained ResNet 34 model so that vanishing gradient problem can be resolved. And the fifth step is to compare the feature vector with non-embeddings using distance metric. We use Euclidean distance for that. And if the last step is to identify the face if the distance is below the threshold. After finding the distance metric, we compare it with the threshold, and if it is below, if the distance is below, then the face is recognized or the verified. Moving on, and this is data flow diagram for level 0. The user uses voice commands and ways data login. Okay. This is level 1. Here we
skip the diagrams, data flow diagrams.
Okay. This is implemented screenshots here. Welcome page to verify.
Previous slide, please.
Okay. This is the menu page.
Before that.
Okay. Hello.
Previous page. Previous slide.
This diagram.
Oh, okay. Carry on.
Okay, this is the menu page, and from here we navigate through voice commands. First, if you want to log in or
explain, you just.
Okay. The functions in this, the functions are inbox, compose, send, and trash. We can use voice to navigate to each
next slide.
This is here where we read out the mails, recent mails from the inbox, and this is we can use sending an email.
Next.
And this one, trash, reading out a mail from the trash, and maintaining trash for effective use. And this is composing using voice command. You can give a recipient's email and subject results and output. Email composition sending. Users can compose and send emails via voice commands with 90 to 95% SDT accuracy. Text generation using AI, Rogue One recall score calculates 98% of the original description is present in the AI generated text. Then seamless Gmail API integration. Efficient handling of emails with 99% syncing accuracy, including spam and trash. Moving on, advantages. Accessibility for visually impaired users. Hello?
Skip it.
Okay. The challenges we face. Coming to challenges.
Conclude it.
Okay. Future scope. Okay. The development of voice-based email system for visually impaired users marks a major advancement in digital accessibility of visually, enabling users to manage emails independently without relying on other visual aids or keyboards, making them very effective for visually impaired users. The system makes email management more efficient and user-friendly by incorporating voice commands, allowing users to perform essential tasks like composing, reading, and deleting emails hands-free. That's all references. Thank you.
References? No references?
Yes, references. Wait, let me share my screen once more. There is references.
What is HTT engine?
Speech to text engine. We used WebKit speech API for speech to text.
Okay, in your paper, you had pasted so many screens. No need to add
This is the
screens.
one speech.
Excuse me.
This is the reference page we got. These are the references we took for the project.
Oh, okay. It's not in a right format.
Oh,
okay, in your paper, you had pasted so many output screens. No need to paste the output screens in the paper, in conference paper, okay? Also, the content is, again, the content is generated by ChatGPT. You are not allowed to write accuracies like this and all. You also wrote like this.
Actually, our modules are like
How you got
we
the
use
accuracy? How you got accuracy?
the accuracy. First of all, we speech
You
to
have to
text we use.
prove. You have to
Okay,
prove
okay.
our
Okay,
accuracy is this thing, using some measures or mathematical formula, something like that.
we
Otherwise,
used
you can't
we used
write. You can't write.
okay. Okay. But we
Okay.
used Google's Web Speech API demo for texting and the words speech to text. The speech is recognized as text and the words are aligned properly so that the accuracy can be calculated.
It is used.
Google's Web Speech API demo for texting the word error rate and character error rate.
Oh, okay. Which API is used here?
Google WebKit Speech.
Okay. What are the parameters needed for the communication?
Actually, discussing with parameters.
Okay, it's enough. Okay.
Okay.
It's okay, sir. Let's move to the next presentation. Hello, last presentation. Smart exercise assistant.
Hello.
Yes.
Am I audible?
Yes, you are audible. You are the last batch?
Yes, ma'am.
Okay, you can proceed.
Hello, is the screen is visible?
Yes, it is.
Okay. So good afternoon all. My name is Praveen Kumaras and I'm here to present our paper, Smart Exercise Assistant. This work was done with my co-authors, Muhammad Anwar Shah, Ashna Siraj, Archana Rajendran under the guidance of Dr. Shama Das. Our paper focuses on using BlazePose and CNN LSTM model to correct the exercises. So, going to the introduction. Daily exercise is essential for a good health, but incorrect posture will lead to severe impacts. And hiring a personal trainer can be expensive, and not everyone can access this. So our smart exercise assistant aims to help the users to maintain their proper exercise during the workout, enhancing the safety and the effectiveness. So the problem statement is to develop an efficient and a precise solution to provide real-time feedback on user posture during the workout. So our objectives of the project are to develop an AI-based system to recognize and evaluate exercise postures accurately, helping the users to maintain the correct form and avoid the injuries. And it also addresses the challenges such as identifying the complex body movements, providing real-time feedbacks, and ensuring recognition accuracy across various user anatomies. So there are various existing systems. One of it is PhysiApp. It uses AI and ML to analyze whether the patients are performing the exercise correctly. And there is another existing system is VAY Sports. It is used for a real-time correction for workouts, ensuring correct execution of exercises. So the limitations of the existing systems are there are many existing systems, but some of them only provide the real-time feedback, and there is no repetition counting, and there is the users cannot customize their interface, and many of the existing systems are based on sensors. So literature surveys conducted on many papers, and here there are two papers are included. First one is Blaze Pose on-device real-time body pose tracking, which is published by the Semantic Scholar. And the methodology they used is convolutional neural network architecture for real-time human pose estimation. Their result is they used Blaze Pose and Open Pose to extract the key points. The Blaze Pose work more efficiently than Open Pose. And their limitations are it is based on face detection to track the persons, and there is only a single person tracking. And the second paper is published by the ResearchGate. They used the methodology of video recording, then pose estimation using the Open Pose, then key point normalization and perspective detection and providing the feedback. They have improved this paper has improved correction than the before paper, which I said above, and it has limitations like a limit. They have limited exercises, and there is also technical barriers like installation requirements and device compatibility, etc. And our proposed system utilizes CNN LSTM self-attention architecture, where CNN extracts the spatial features from the key points, and the LSTM captures the temporal dependencies in movement sequence. Self-attention enhances the critical time steps, and the fully connected layer with the softmax classifies the exercise postures. So this is the diagram of the proposed system. It consisting of different layers. At first, the key points are extracted by using the Blaze Pose, and it is given to the input layer. And that key points are then given to the convolutional layer, where the spatial relationship is extracted. That is a distance between the key points or joints like that. Then that is given to a sequence layer, where the 4-dimensional data are converted to the 3-dimensional data. Then it is given to the LSTM. The LSTM means long short-term memory, where the temporal relationship is verified. That temporal relationship means how the key points change according to the time. And then it is given to an attention layer, where the more attention is given to certain key points which is needed for that exercise. Then it is given to a fully connected layer, which classify the different stages of the exercise, which means in some exercise there may be up and down stage. It is classified in fully connected layer, and the output layer, the last layer is the output layer, which predict whether there is error or not. And this is the system architecture of our proposed model, and there is a user interface, and the user can upload the video, and which is given to a pose detection module. The pose detection module identifies the key points by using the Blaze Pose, and then that key points is given to a pose classification model, which identifies the correct, which is the stage of the exercise, up or down, and that is given to a error detection module, which compares with the error detection logic, and the feedback is provided to the user. So the methodology is first methodology is exercise selection. Mainly we are focusing on 4 exercises: biceps curl, plank, squat, and lunges. And each exercise has at least 2 errors. That is improper posture, or there is an error in the placement. So this aim is to train a deep learning model to detect and correct these mistakes. So the methodology means the next step in the methodology is data collection. the data collection involved collecting two types of videos, that is the correct form of the exercise and incorrect form of the exercise. And then the blaze pose is needed. The blaze pose is actually used for extracting the key points. So a video consisting of different frames, and each frame is given to a pose detector which identifies the key points, and the pose tracker continuously identifies the key points while the video is going from one frame to another. Then we use the formula for distance calculation, which is basically used for calculating the distance between two key points. Then an angle calculation, which is used for calculating the angle between the key points. And here the angle is found using, here the angle is calculated as degrees. Then we want to convert it into radian. That formula is given here. Then the data pre-processing, which means the videos are collected, then it is given to the media pipe pose. Here we are using blaze pose, then extract the key points, and then that key points are stored in a CSV file. And the CSV file is of two types, that is training and testing. Then the error detection for each exercise is given here. For the first exercise squat, there are two types of errors, that is foot placement is too wide or too tight or wide, or the knee placement is too tight or wide. For the first error, we calculate the ratio between the feet and the shoulders. If that ratio is between 1.2 to 2.8, there is no errors and the exercise is doing correctly. And for the second, the ratio between the knee and the feet is calculated. So this is the graph regarding the feet placement. If it is between 1.2 to 2.8, the exercise is doing correctly. And this is for the squat knee placement. And there are three stages: up stage, down stage, and mid stage. And this is the graph where the exercise is doing correctly. And the next is exercise is lunges. For lunges, the errors can be arise if the knee angle is incorrect or the knee is over the toe. So if that for in knee angles, the angle is between 60 degree to 135 degree, the exercise is doing correctly. And for the knee over the toe, the same procedure is for it also. And the graph for the lunges is here. And when it is doing correctly, it must be in the range between 60 degree to 135 degree. And next is a bicep curl. In case of the biceps, the error can arise if the angle between, if the arm is not placed correctly. So first of all, we have to calculate the angle between the body and the shoulder, the angle between shoulder, elbow, and elbow to ground. If it is exceeds 40 degree, the hands are not placed correctly. Or if the angle between the wrist elbow and the elbow shoulder is greater than 60 degree, there it is no, the exercise is incorrect. And the third error is leaning too far back, which means if the back of the person is not in a straight line, which means he may be leaning forward or backward, the exercise is incorrect. So it is also an error. And coming to the fourth exercise, it is plank. In case of a plank, the plank is similar to the push-up, where the back must be in a straight line. So if the person's back is too high or too low, there is chances of error. And these are the exercises we are used, and the data set for the squat lunges are given here. So the first parameter is the corresponding position, and the next are the corresponding values of the ratios and values. And this is for the lunges, and this is for biceps and plank. And these are the implementation screenshots of our website. And the results are for squat, our proposed work get an accuracy of 99%, precision 98%, a recall and F1 score of 99%. And for the lunges, we get a accuracy 95%, precision, recall and F1 score of 95%. And for the bicep curl, we get accuracy closer to 90%. And for the plank, we get an accuracy closer to 98%. So this is the accuracy of all the exercise in a single table. So these are the results of the persons. And the third picture, there is a blue color, which means the exercise is doing correctly. And the other three pictures, the lines are in red color, which means the exercise is doing incorrectly. And so coming to the conclusion, the system functionality. That is, we use blaze pose and deep learning to detect the poses, classify errors, and provide real-time feedback and correct the posture. And the benefits are enhances the workout effectiveness, prevent injuries, and help engage the right muscles. And it offers a scalable, personalized virtual trainer solution for all the fitness level, ideal for home-based workouts. And the future scopes are it can be integrated with VR or virtual reality for better error correction, and workplace wellness programs can be integrated with this, or healthcare and rehabilitation can be improved by using our solution. So these are the references, and thank you.
Okay, actually, work is good. You have to improve the formatting of references.
Okay, ma'am.
Your paper is also good. But most of the contents are generated from ChatGPT again. Don't use bullets in conclusion. Okay, which model is used for this post detection? Hello?
Ma'am, we are using blaze pose to detect the key points, and then it is
How
given
many
to
key
CNN.
points are used in your work?
Using blaze pose, we can detect 33 key points, and according to the exercise, it may be changes from changes. It may changes.
It may changes up to how many?
About 5 to 6. We need minimum 5 to 6 key points.
Okay, in your paper you wrote that after training the model is saved in a TensorFlow.js format. Which model is saved into a TensorFlow.js format? There is little bit confusion in this.
Ma'am, the model we used is LNN, LSTM CNN self-attention model, and it is saved in the TensorFlow because deep learning models are included in TensorFlow library.
Okay. Okay, work is good. You have to improve the paper little bit. Compared to other papers, this is a good one.
Thank you, ma'am.
Okay, I think you are the last presenter.
Invaluable guidance and for fostering a discussion that has enriched our understanding of these research contributions. Sincere thank you to all our presenters for the dedication, meticulous research, and well-articulated presentation. Your contributions are shaping the future of intelligent computing and secure technology. Finally, we extend our formally conclude this session, we look forward to your future work and wish you all the best with your research ahead. Please turn on your cameras for the photo. Everyone, please turn on your camera. Am I audible? Thank you all and have a great day ahead.
Thank you.